Alright, good afternoon. Welcome to the class again. So, although I wrote that this will be a tutorial class, but we will have a lecture instead. So here we were in the morning class. So we talked about how the different types of membrane configuration can be. So we will discuss them one after another, how the membrane configurations can look like. Regarding the membranes configurations, here is the configuration is called a tubular configuration, and when we talk about tubular configuration, they are basically we have see here, this is a membrane which is a membrane material, but it's a ceramic membrane. So if you can have a look at the ceramic membrane surfaces, see here we have a layer. So this is made of mostly ceramic, aluminum material, and the ceramic membrane, so alumina is sintered to form a monolithic Mora-7. So it's a kind of a monolithic block type of thing, and as you can see, there are pores inside or channels created inside, and the whole thing is there with the channels, and you can see here that here, if you look at this ACM image, so this is an ACM image of whatever there is. If you look at this particular area, so the surface has been imaged here, and if you look at the surface, what is there, you can see there are two different layers here. So one is like this, and another is a layer with bigger size material. So here you can see very small size material and lying on top of bigger size backing layer. And so this is like we can call it a selective membrane surface, and as such, this top surface is the one which actually gives you the filtering ability. And here you can see the alumina is sintered here. So alumina powder has been sintered on top of your support. Okay. So what happens is that we pass this water from here. On this side, the water is fast, and it gets into this hose, and you can see the feed stream flows through the channels. So feed stream flows through the channels and permeates. They come out of this side from here, the permeate stuff. So the whole thing is, so the water comes in here and gets, and then it comes out. Okay. So this is how this thing works. So feed stream channels within the force structure are lined with a selective material we are talking about here, and pore diameter is fixed to 5 micron, and the permeate produced by the membrane passes relatively uninhibited through the porous layer. So this is how a tubular membrane would look like. So this is what tubular membrane, but this is a ceramic material, and so it can withstand very high temperature, because if we compare them with normal membranes, which are basically polymeric membranes. So they have a, they can stand temperature to certain degrees centigrade, let's say about 200 to 400 degrees centigrade, but above that temperature, we don't see any membrane withstanding the temperatures. So this is how this membrane works, and there are other membranes. So we talked about the hollow fiber membranes. So you can see the hollow fiber membranes have different types of sizes and different types of different applications. Now you can see that so this is 50 to 200 micron in diameter. This membrane is and so it is used for hydrogen gas separation or reverse osmosis hollow fiber membranes. And PSIC is the units. This is 40 PSI and 300 to 400 micron diameter. They are also gas separated membranes. And normally, if you see the hemodialysis, which is nothing but the dialysis or process in which the particles the blood particles are separated. So these are like hemodialysis fiber with having 500 to 2000 micron diameter, so that means 2 millimeter diameter, and this one is 1000 to 2000 micron diameter, and this is ultrafiltration capillary fiber. So the pressure requirement for this is 10 to 15 degrees. Okay, so these are some of those membrane hollow fiber, and we normally come across. And as you can see that the size is like possibly at this particular vacuum layer. So this is the vacuum layer of something as this permeable part, and the water either can get in or can come. So it can be an inside or outside in type of system. Okay. So this is our hollow fiber membrane. Now, as you have seen, these hollow fibers are like very thin wires through which the water can pass, and so the hollow fibers can be having. Yes. Any question? Okay, so we have been discussing the hollow fiber membrane, and normal configuration of hollow fiber membrane is just like this. You can see here, this is one configuration, and these are hollow fibers inside here, this membrane. And if you like to see a diagram here, how it looks like here. So let me add this hollow fiber membrane. And so if you try to have a look, you will see that this membrane is actually you have these fibers right here. So you can see these fibers right here. So they are kind of attached to the plate right here. Okay, so they are attached to this plate, and so each of these fibers like this, as we discussed before. Okay, so each of the fibers will be Okay. So each of the fibers can have so it can be like this, and we can either outside in, or we can have from inside out system. And here, if you have a look at how the system works, this is an outside to inside system. How I can get this as an outside to inside system. So this is like this. I'm sorry, some problem. Alright, so what happens, let us see what happens here. Okay. Alright, let's have a look at here. You have a feed line here, and this feed actually passes inside, and it comes inside the membrane, and what happens here we have all this ends are here, so this is one end, and here this end is here. Now what happens is that the water gets in, and it fills up all those pores. All the inside is filled up. So the inside is filled out with water, and for each of these membranes, this is what happens. The water comes from the outside and goes to the inside. Okay, so as it goes to the inside, the particles or the contaminants are lined up at the outside of. Okay, and the pure water gets into, or treated water gets into the lumen of the membrane. So it known as lumen of the membrane. So treated water gets into the membrane. And now you can see this part is out. So this is, this is dead end. So we call it a dead end. So we have a dead end here. And now the water has nowhere to go, but it comes through this end, and from here it actually opens up right here, which is the treated water or permeate is collected. Now throughout this feed is under pressure. Okay. So you are feeding this under pressure, and when you are feeding this under pressure, then the water cannot pass from here, because this is there is no way that the water can, except it can get into the place, or there is a out here, which is a reservoir. So you can actually put a valve there and allow only a small amount of water to pass through. So the pressure is built on, and the water only gets in from here, permeate side, and the flow of water can be controlled by operating the valve, which is outside. So this is how this module generally works. Now what happens that as you go on doing this, there will be a build-up of solids outside the membrane. Okay. Or maybe if you are doing inside out, then you have what is called the solids will build up inside. And so what happens is that let's say this is the membrane wall, and so this is the build-up of solids which are there. Now, as the solids build up, as we know, we have gone through filtration processes. The pressure requirement to maintain the flow rate is going to be more and more. So, in other words, so delta P across the membrane. So delta P, or the pressure drop across the membrane, will increase over time. So delta P is the transmembrane pressure required for creating the flow. This will increase. Okay, and so with time, delta P will okay. So this is how this membrane will work. Now again, if you see, if there is a delta P, there is a now here in this case the flow is exactly opposing the direction. So you are actually if it is inside the membrane, the flow is taking place opposing the membrane. So it's counter flow type of device. Now if you say that we have a different type of arrangement, let us say the flow is in this direction. So normal flow is in this direction, and you are allowing some of the flow to get in this direction. So what happens is that in this case, the total, of course, there will be the solids build up. So solids will build up, but what happens is that the solid build up will not actually create hindrance to the normal flow through the device. Okay, so it's called cross flow situation. It's called a cross flow situation, and you can understand that in the cross flow situation, the pressure drop will not be as high as this one, because this is opposing the flow, but this is not opposing the flow. This is just creating enough pressure so that there is permeate that we get from it. So there will be this side, also there will be this type of. So this is how cross flow look like. Okay. Now, for cross flow devices, basically you can see that if this is one end, let's say this is A and this is B, and same water, when it is at A, the concentration is Ca, and let's say if it's a concentration at Cb, of course your Cb is better than Ca, because the concentration increases, because some of the water gets permeated out. So the concentration of your content increases. So at the end of this whole thing, you will see that the concentration actually rises to a very high concentration. So here also you can see that the flow is along this direction, and this direction, and some of the flow is actually taking place through the membranes. Okay. So it's basically a cross flow device, and this is called polyfiber module with shell and tube type of. So now if you look at this particular module, so this is shell, so this part is shell, and then we have the fiber right here. We can have number of fibers right here. So only one fiber is shown here, and you can actually see if this is a feed, there will be a pump which will feed the water from here inside. And so this is, and there is nowhere to go for the water. So this is a dead end right here. Okay. So this is called a dead end filtration. And it is actually taking place in outside in type of configuration. So this is outside in type of configuration and right here. Okay. And this one is inside out. Of course, this is a dead end filtration, but so the inlet is from here. So this is the inlet from here, and here you have the pump. Okay, so you have pump right here. Okay, and you can see the water flows in, and then so this is nothing but inside out of configuration, and this is where you get the permeate right here. Okay. And there might be another type of configuration, so which is a cross flow module. So your inlet is from here, and you have kind of your permeate is from here, okay. And this is also called retented or the residue. Okay. So this is the center. Okay. And if you say this is CF is the concentration of feed, and your concentration of permeate is CP, and so because CP is much less than CF, because this is your treated water, then you can very well understand that in that case C waste, so the concentration of the retentate will be much greater than your CF. Okay. So this is how shell and tube type of device will work. Next, we will try to look at another type of device, which is called a submerged system. So this is known as a submerged system. Please try to have a look at this submerged system. You can see that this is a part. So this is the whole part. And so here you can see that just have a try to look at here. So this is called a manifold. Okay, so this is called a manifold, and it is almost like this. So if you look at this particular thing here, so this particular bar kind of thing that you see here, so this is nothing but a manifold where this is, there are small connections right here. These are the tube bundles or hollow fiber membranes are attached with this, right here, and and these are hollow fiber membranes. Now, what and so this is an inside outside in type of configuration. You can see this is an outside in type of configuration. Okay. Now so these are all cassettes because they are modular in construction and they come like cassettes here. And if you can see here that how this thing works is that these cassettes are inside this type of submerged this fiber, these cassettes or modules are submerged within water. Okay, so which water? The contaminated water. Now you can see that there is this is just a part of your the container in which this is there. So this is the entry. Okay, so it enters from here, and this is the influent water pipe through which the water will go, and then the water will come and and it will be under pressure. And what happens that the membranes will, the water will try to go from outside to inside these membranes. So it goes from outside to inside of the membranes, and all these membranes are actually ending on this manifolds. So these are manifolds or larger size pipes where all these things are connected. So you can see manifolds down there and up here also. So all these manifolds are connected, and they are connected with the central manifold, which is this one, and this manifold is connected from outside. And now treated water will be drawn by vacuum. So you can have a pressure here, or you can create a vacuum right here, so that when you create the vacuum, the water kind of gets sucked up from the outside to inside, and ultimately it goes out. And so you have this permeate collection manifold which is here, and this is how this whole thing works. Now the submerged membrane modules are like this. So normally the vacuum is created rather than the external pressure creation. So vacuum creates, and this under the vacuum water is sucked in, and the retentate are, as the time progresses, the concentration of the outside actually increases. So if you try to look at this thing, this particular situation, this is called feed and lead type of device. And see what is this? This is you can say this is almost like a very it's like you feed this from here, and you create the vacuum and you take out the part. And what happens is that as you have number of such things, as the water progresses from this side to, so you have number of such things, and as the water progresses from inlet to the outlet, or from here to here, from here to here to here, so the concentration actually rises, and you can have an outlet where you can take out the concentrated water right here. So it's a kind of a plug flow type of device. The major pathway for water is this, and the treated water is taken out, and the more concentrated water will be taken out. Now this is another concentration which is called a semi-batch type of configuration. So here you can see that of course we are feeding from here, and the suction and such an permeate water is almost similar, but the outlet is now based on the overflow now. So you have a overflow type of configuration created, and and this is how this is. So normally what happens is that in this system, the particles, if any, will try to settle down, and what you have, in the overflow trough, the water will be kind of devoid of solid particles, so that there is no choking in the outlet or whatsoever that we can think about. So this is the submerged system. We have permeate here, and this is the feed, and we have, if you look at this diagram, we have a wastewater outlet right here. So this is the, okay. So the wastewater outlet is right here, and then if there is a this type of device, an IGAS type of device, so obviously we will have a outlet overflow here or overflow class right here. Okay. So this is one configuration, and then we will talk about the plate and frame type of module. So this is known as plate and frame type of module. Okay, so plate and frame type of module, how does it look like? See here, we have here we use paper or flat sheet type of, not like the fiber. Here we use a paper membrane, which would be like this. So this is almost like a flat paper, and if we have the feed right here, so the feed is right here, and the treated water will be available from the water. Okay, and so we call it, so these are the treated water. Okay, and of course we call it permeate, and this is your feed. Okay, and the particles will get collected over the active side of the membrane. We can also have it like this. Suppose this is your membrane, and your flow is along the membrane. Okay, and so some of the flow will try to pass through the membrane like this, just like fast flow device that we talked about. Okay, so the water will try to pass through this, and so this is a cross flow type of situation, and you get the permeate water right here. Okay, so this is the permeate. So anyway, what you understand is that this is a device where we have a lot of membrane envelope right here. And here, if you can try to see, this is the feed that we allow from here, and the feed actually comes through this device and comes through here. And now each of these is there are small channels created along this, and as this passes through these tapers, each of these membrane envelopes. So you can see this one is support plate. So one of them is a support plate, and so this is the support plate right here. Okay, and this is the membrane. So on top of this support plate, there is this membrane. So what happens that the support plate is porous, and on which the membrane envelope is wrapped around. So it goes through the membrane and it connects on the support plate, and the support plate actually takes everything and discharges into this particular side channel, which is so this channel, as you can see, this is the channel for permeate. So you can see this is discharging into the permeate channel, this is discharging into the permeate channel, and this side also the similar thing, it will be discharging on the permeate channel. So obviously you can understand that the water goes through a lot of tortuous paths, and finally the outlet is here. So you can have a little bit right here, and then obviously you can so the whole thing can be pressurized, and this is like this is one this is within one plate. So this is called a plate and frame kind of stuff, and you can see this is the tension nut which we can tighten and to make this pressure or sturdiness of this plate and frame device to be right there. Okay, so these are main configurations of some of the configurations that we can actually use, and there are many other configurations for the ultrafiltration and microfiltration methods. Okay, so there is another configuration that I will discuss it in a while from now. Okay, let me discuss it right now. Okay. Now, so this is called again this is one type of so this is I mean you can see here that we have some internal inner core support right here. This kind of a spirally wound type of device. Okay. Try to have a look at it first, and then I will discuss it in detail. Okay, alright, so this is just like a this is another figure that you can see here. This figure is like a number of tubular modules that are created right here, and but this one is basically you have the membrane filter wrapped within a spiral form. See, this is a fiber pre-filter, and then you have a 0.2 micron membrane filter, and we have a support plate. So these are these three layers. See, this is pre-filter. So we have filter right here. Okay, and then we have the real filter. Okay, so we have the filter here, and we have the support plate, which is right here. So these three together forms one assembly. So you can place them together and it forms one assembly. And then you can wrap around this particular inner support core. You wrap it around the inner support core, and this actually makes the whole spiral wound system, so in which you can actually wrap around the whole thing around this. And maybe we will discuss this particular spiral wound system when we discuss the reverse osmosis methods. Then I will try to demonstrate how it actually works, and then you will be kind of understanding that video. Right now, just try to understand that this is the a long piece of cloth or long piece of paper which are pasted together, and actually this assembly is our filtration assembly. The water goes through this and percolates right here, and then the central thing is you have a and this water moves through spiral rings and it gets collected into the central channel. So this is the central channel that we are talking about, inner support core, and this water everywhere the water gets collected and moves inside a spiral and gets collected right there. So in this type of configuration, we can actually have a lot of membrane area incorporated in a very small fluid bed area. We'll talk about this real soon, but before that, let me move on to the next section, which is about what are the ways that the membrane works. Okay. Now you can see that one type of mechanism is cake formation. Okay. So what happens is that, see, these are the channels that are created. So this is just the thickness of your membrane. So it's the thickness or cross section of the membrane, and this is about let's say 0.1 millimeter thick maybe. So this is the thickness of the membrane, and then we have here the gaps are about the gaps which are created. They are about 0.1 millimeter, 0.1 micron and below. So what happens is that right here the particles that get deposited right here, but these are the channels which actually takes out water. Okay, so the channels are shown here straight, but they may not be straight channels. So they may be tortuous channels, but these are how this thing works. And then here, these particles which are written here, so these are retained particles. So retained particles, they form a layer like a cake layer. So they form a cake layer right here. And that actually over time, what happens that it creates fouling of the surface of the membrane, and for this the delta P value or transmembrane pressure value it increases. Okay, so it goes on increasing as the time goes and cake layer is formed and the thickness of the cake layer is increasing. So another type of is device mechanism is called pore constriction. So what happens in post-pore constriction is that so these are pores created right here. Okay, so this is just again another type of membrane. This is the cross section of the membrane, and you can see the membrane is not like long interconnecting channels or long through and through channels. This is just like different types of pores are provided here. So what happens is that when you do the filtration or you add the water right here, of course at the top there will be formation of the cakes, but it is not a layer like this. It doesn't have that much of, so some of the particles can get into, and it can, but inside this tortuous channels the particles can get back. Okay, and also this is like hydrophobic, so these are hydrophobic. So if you have hydrophobic substances, they will be absorbed onto here. So because of the hydrophobic interaction, they will be absorbed here. So hydrophobic substances are absorbed right here. Okay, so this is the pore constriction, and this one method is called pore blocking. Now this is almost like a depth filtration, that you can understand that this is mainly for microfiltration and ultrafiltration membranes. This is one of the primary methods that you can think about. So this is almost like a depth filtration process. So here there are polymeric nets of polymers. The membranes, the thickness of the membrane is like this, and the pores are created in such a tortuous way that the particles get trapped within the pores, and this is how this pore blocking thing works. And of course, yes, this is how it works now. So this membrane, this polymers, can be hydrophobic or hydrophilic. So hydrophobic or hydrophilic polymers can be of two types, hydrophobic and hydrophilic, and they have a lot of say when you talk about the fouling propensity of the substances. Now let us have a look at the different types of filtrations. So this is just an ACM image of the top of a filter, and it's not a very high resolution and highly magnified image. So you can see the bar here, 10 micron is the size bar here, and so you can see that this is like this. If you look at from the top, these are all punched holes on the membranes, and as you can see, the holes are of same, are uniform size. So this is called a screen filter, and the pore size is 0.45 micron. So here it is written screen filter with 0.45 micron, and here there will be a lot of cake formation because it is a surface filtration that is taking place. So this is almost like this one is right here. Now when you talk about pore blocking and pore blocking type of membrane, so this is the ACM image of this. So this is the ACM image of depth filtration or pore blocking. This is also 0.45 micron, but you can see that the surface here you have bigger size holes. Okay, so the water can with the particle can get inside, but this is the photograph from the surface of it. So the LCM image actually gives you the image on the surface, but doesn't tell us about what happens just below the surface or at a depth from the surface. So when you can, if you look at here, so from here you can see that, well, we have a big size pore right here. Okay, so we can have bigger size pores, but the pores are not continuous. Just like this one is not, pores are continuous, but this here pores are not continuous. So maybe a layer below we find that, so these are blocking, these are polymers, the white color ones, and the black ones are dark circles, are the gaps. So you can see that some of these are on the surface, so some particles can get trapped on the surface, but some of them will just go below the surface, maybe in the depth, but ultimately they will be trapped right there. So if I try to understand which one is how, in the which one have the highest fouling propensity, so between speed filter and the depth filtration, which has the fouling propensity higher? Can you tell me, one of you? Which one will have higher propensity for filter? Yes, screen filter will have higher tendency for fouling because it does only filtration at the surface, but here that's because for the depth filter the filtration is throughout its body, or throughout its cross section. The fouling propensity is less. So fouling tendency is less for filtration at the surface. Fouling tendency is much larger. Okay. So here we say we talked about this. I don't want to get into again with this. So this is nothing but just a microfiltration system, and this tells us why inline and cross which one we have less amount of case of cross flow filtration. Now, as we understand that
हाँ सर नमस्ते, मैं चित्रकूट से बोल रहा हूँ धीरेन्द्र। आपने जी सर, हाँ जी सर, आपने आज के लिए बोला था कि फोन कर लीजिएगा। जी सर, धीरेन्द्र कुमार सन ऑफ श्री कला प्रसाद।
we have cellulose acetate,
जी सर बोलिए।
we have
जी
fluoride or PGPF, and then
RU 7695
we have aromatic polyamides.
43 है।
These are different types of elements are there.
107
we can cast
जी
different types of systems.
107 क्या आगे?
Between
IN
some of those
जी सर, वो है ये बता दीजिए, इसकी जरूरत नहीं है। जी जी
you don't have to remember this.
जी जी जी, थैंक यू सर, बहुत बहुत धन्यवाद।
So here we can easily take the plastic solution and the water and to put in different types of anisopropyl. Now you will see later. The distance of flow across the medium. Now If you have a look at the one of these membranes, sponge structure passed from the concentrate nomexin methyl acetamide. So you can see here in this diagram, so at the top, you can see that this is the
कहाँ?
section,
कहाँ
skin cross section, and you can see dense layer right here. But if you try to look at within the membrane, which is here, and you can see this is not as dense as this one. So okay, 2 micron size, 2 micron size. But here, there you don't even see the post right here. Okay, and here also at the bottom you can see bigger size post, almost like 5 times or bigger size. So you have the bottom skin also almost like this. So, and also we have finger structure passed from dimethyl acetamide, and you can see that only the top layer, the top skin, if you see, only the top skin has a very thin layer of membrane.
बहुत से बात कर रहे हैं हम वाला बोल रहा है ये कसम
They are very porous in nature, and so once the water percolates to the membrane, so they have a very easy passage to the membrane. So and this this particular type of configuration, will be much less than this type of configuration. So this is what we say about membrane configurations. Of course, when we are talking about this, these are all core type of membrane because nature of membrane. We are not talking about it. So I am stopping it right here. So next day we will talk about different types of membrane materials, how they affect the performance.
पता है पहले तो आप बताओ कि
And hopefully in the next class I will complete this part and we'll go from
तब भी गई हूँ
Okay, so that's it for now. And if you have any question, I can answer those questions, or otherwise I'll let you go. So do you have any question for me today? Okay, so if you don't have any question, let's call it a day today, and I will see you guys.